Okay, well, hi everyone. I'm Daniel, and I already met some of you yesterday, and I don't know if all of you were here on Wednesday, but we already started with this Speedrun Ethereum course with Leo. Leo gave the first talk on Wednesday, and we're going to continue today with the second lesson. Okay, I'm Daniel. You can find me everywhere. Like this, Daniel0AR. I don't know if it's too small to see, but Twitter, GitHub, everywhere. I'm a Web3 developer, and I do mostly front-end and integrations. Yeah, but I also work on smart contracts and yeah. So as I said, today we're continuing the challenge for the Speedrun Ethereum. As you already know, Speedrun Ethereum is a program for you to bootstrap your Solidity skills and your smart contract development, okay? So we can all go, you can follow me or you can follow the guide from Speedrun Ethereum itself. This is on speedrunethereum.com, right? You can enter Speedrun Ethereum and you can go directly into challenge 1. Right, and here you have every step that we're gonna follow today. Okay, and what are we building today? We are going to build a staker contract. If you are familiar with cryptocurrency staking, you already know what this means, but it's basically just sending crypto to a contract, and then the contract returns some rewards for you. But in this case, we're just going to work on the sending logic, the receiving logic, and we're going to work on error handling and using some modifiers as well. This is just this is the second lesson, so it's not too advanced, but we're going to have some pretty interesting details now. And here's the finished app. You can see it here. You're going to have how much stake ETH you have, how much crypto you have in your vault, the total crypto that every user has had in the vault. This is a general vault that everyone can send ETH to. And you're going to have just two simple methods, the execute method and the withdraw method. The execute method is going to finish the contract and allow the users to get the rewards. And the withdraw is the one that it's going to allow the users to receive the rewards, okay? And you're going to have a button here that takes the Ether. Okay, so we're going to start now. Okay. I already have a question here. Okay, that's it. First of all, the requirements. We're going to need the node, right? Here it says version 18, but I tested with version 20 as well, and it works. If you have version 20, you can use version 20. If not, you can install node version 18. And you're also going to need Yarn. And I believe you already installed this on Wednesday. If you are not here, or you are used to using Yarn, you have it already. And Git, of course. So first we're going to clone the repo for this challenge. Okay, is it okay for you like that? Yeah. Let's finish up these things. I don't know if you submitted the challenge number 0 on Wednesday, because here on the platform you can submit the challenges that you do, and they will grade it they will track your progress in the Speedrun Ethereum. It's very cool. Yeah. Okay, so it's cloned now. And if you have any questions, you just raise your hand and I will answer them. You can interrupt me anytime. Yeah, so we go inside the folder that we just cloned, right? I don't know if it's okay, the font size. Let me just screen.
Yeah, the terminal, can you just make it bigger?
Yeah. Oops. What the hell? No? I increase it a bit. Maybe it's better like that, right? Yeah. So now that we're here in the folder, we're gonna install the dependencies, right, with yarn. Oops, install. Okay. And we're gonna run this command yarn chain. Yarn chain is gonna start local chain for you. I'm sorry, what happened here? Did I clone the repo? Oh yeah, I forgot to switch branches. Okay, so in this repo you have many branches with the different challenges. Okay, so we're gonna switch for the branch of this challenge, the challenge 1. Oh my god. Run again. Right. There we go. As I said, the yarn chain is going to bootstrap a local node for Ethereum, right, or the network. And here you're going to have 20 accounts that you can use and tinker with 10,000 ETH each, right? This is just on local. You can access this network in this URL, and this is going to allow us to launch our contracts or deploy our contracts locally without using a real net test it or it, right? It's always better to start on local development and then move on to using a testnet. So now we have the chain running. We're going to open a new window, a new terminal window. And we're going to start by deploying the contracts. I'm sorry, over here. Yeah. And in a third terminal window, we're gonna start the application. As we're following the Speedrun Ethereum, we already have our front end set up for us, and this front end is gonna help us with a smart contract debugger, an interface which is already developed, and then some functionality that we can use right after installing the scaffold E2. So we're gonna start the front end with yarn start. Now you can check it right away. Now here's the scaffold interface. I believe Leo already explained to you a bit about this on Wednesday, but here you have some functionality that you can see. This challenge comes with already the staker UI, which I already showed you before, right? And right now it won't work because we haven't done the contract yet, but we're gonna do that right away. And we also have this debug contracts functionality that will allow us to test every function from the contract that we develop here in the interface. We don't need to call methods from the terminal. We don't need to do anything from the terminal. We can call the methods directly here. Okay, so now that we have this, we're gonna continue with the contract. And the contract, yes. We have already deployed the contracts, I believe, right? Or no, we just run the chain. We have the chain running here, and we can deploy. Oh yeah, we already deployed the contracts here with the command yarn deployed. And we're gonna use this command every time we do a change to the contracts, right? So now into the contract, we're gonna start with the staker.sol. You can open up your preferred code editor, right? And you're going to go to the staker.sol. As you can see here, the contract already has some comments in it with the functions that we are going to work on. And they are basically self-explanatory, but you can also follow the guide to see what we are going to work on. So we have here a stake function that we're going to do, a deadline variable, a threshold variable, a time left function, and a receive function. Of course, the most important function here is going to be the stake function, so we're going to jump into it right now. And this is the one that is going to allow the user to send some ETH to the contract, and also track individual balances for every user that calls this function. Okay. So you already learned yesterday with you some of the basics of Solidity. So you already know how to write a function for Solidity. And this is just very similar to some other languages. But we're going to go with the function, and we're going to use a visibility modifier, right? So it's going to be a public function, and the name is going to be a stake. Right now, we're not care about any arguments, so we're going to just leave it like that. And as I said here, this function collects funds, right? And it's going to track the individual balances with a mapping. The mapping, we still don't have the mapping, so we're going to add the mapping as well. And if you are following the guide from the UI, you can copy and paste these commands here, right? We have the mapping for the balances, and we can just copy it in here. One important thing about this balances mapping is that we always try to use mappings for when we are going to search in the future, right? Because the mapping indexes this by address, and it's a more efficient way to search, a more efficient data structure, I might say, as compared to an array or any other structure. Yeah? So we are also going to have threshold that's going to be like a requirement for the contract. If the contract does not meet this threshold value of 1 ETH, for example, we won't be able to execute or allow the withdrawals in the future. So we're going to add this threshold variable as well. I believe we haven't seen yet some conventions of smart contract design, but it's always good to keep your variables grouped like in here, and then go to also keep your events grouped over here, and yes, just group variables, events, and then errors. Okay. If you already coded this stake function, you can test that you have the function with yarn deploy. And you're going to see it displayed on the interface. I don't know if you have any questions up to this point. If you okay. Yeah. Yeah. Here it talks about an event already, but we're gonna leave this for a little bit later. Right now, we're gonna work on the execution of this function, and of course, we have some variables already in Solidity that we can use to get some data. For example, we have the variable message.sender, which will return the address of the user that is sending this transaction, or that is calling this method, the stake method. And we also have the message.value, which returns in turn the amount of ether, or the amount of weight that the user is sending to this function, or with this function, may I say. So to update the balances for this user that is going to call this function, the stake function, we're going to go to the mapping that we already initialized, and we're going to look for the address of the user that is sending this transaction, and it's the message.sender. And we're going to add to the already the balance that he has in the mapping, we're going to add the value that he's sending right now, right? Which is message.value balances. Yeah. Here we already have a warning that we cannot send a message.value to a function that doesn't have a payable modifier here. So we're going to add that payable here. And now it's okay, right? Now we're going to work on the event that we have here. It says add an stake event, emit an stake event after the balance has been updated, right? So we're going to just add this event, which is going to return. Oh, you can copy and paste this from here as well. It is in here, Speedrun Ethereum. I forgot. Oh, it's in here. And now that we have defined the event, the stake event, we can just emit it. As we saw yesterday in the previous lesson, and we can send the values that we want to display on the event like this. If the event receives an address and a unit, we're going to set message.sender, sender, and the value, because we want to keep track of these events. That's basically it on the stake function. We're going to continue on doing some other checks, like for example, setting up a deadline that has time to pass before allowing the user to stake the rewards or to withdraw the rewards. And then the execute function, that is going to be the one that finalizes the contract and allow users to withdraw. Now that we have the stake function, we can redeploy the contract and we can see it reflected on the interface. With the yarn deploy command, you can redeploy the contract and you're going to see it here. All right, we have the stake method here, and the value is always going to be on way, so we're going to have to use a lot of zeros for this. But we can already test this one. And we can send like 0.1 ETH to this function. Oops. Oh yeah, we haven't grabbed any funds yet to our wallet address. So a good thing about Scaffold ETH, which is this platform that Speedrun Ethereum works with, and it's that it already includes a faucet to get some funds. So you can just click this button here and you're going to grab some funds from the faucet. And you're going to see it updated automatically in the wallet. So now I have 1 ETH already in my wallet and I can call this function. Scaffold ETH also includes some good transaction receipts. If you are a more advanced user, you can see some of the details of the transaction here, right? We had a notification that it worked, and we can check it that our balance has updated with 0.1 ETH less than we had before, and now the staker contract has a 0.1 ETH in the contract. We can also see it in the UI that is already done for us. You can see that the user 0.0x96, have staked 0.1 ETH, and then the total stake is 0.1 ETH as well. We can also test. You have any questions? No. We can also test the button for staking the Ether. So now the total stake is 0.6 ETH, and everything is working right. Yep. Any questions here? No? No? Okay. If you would like to check, you can check also the balances for the users that have already deposited some ETH to the Vault contract. We can, yeah.
I have one question. The event is only for appear to the wallet when you interact with the page in MetaMask. The event is for came back the event that you bought or stake or something.
You mean using MetaMask instead of this?
When you use MetaMask or using that, the event is for send to
the what? Sorry.
What?
The what? Sorry.
The event is for
the events. Okay.
Yeah, the event is for send to the user the event that the stake is okay.
Yeah.
For that.
Yeah, the event is usually used by frontends. For example, when you see here that I send some value here, if I don't have this event, I will not be able to send this notification that the transaction completed successfully. And with the event, I can keep track of the amount that was staked, and I can even show it in the interface, right? So events are useful for this.
It's only for sending messages.
Getting some feedback, right? Yes. I don't know if it shows in here, but well, in the Block Explorer, you can also see the events, and this is also used by subgraphs and data-heavy protocols that index all this data, and they do like admin panels or dashboards with a lot of statistics and graphics just by keeping track of events. Yes, that's why events are there for. Okay, yeah. As I was saying, you can check the balance of me and the user that sent the transaction, and it's gonna, yeah. Oh no, okay. And it's gonna display that I have already staked 0.6 ETH. So everything is working fine now, and we're gonna move on to the checkpoint number 2, which is setting a deadline and requiring that this deadline is finished for the contract to be executed or to withdraw the funds. So we're going to add this deadline variable here up top. And you're going to see that this deadline uses a very special data here, the block.timestamp. This is a data that is available for you right away with Solidity. And this is going to return the time where in this case, where the contract was created. So for this contract, if we deploy it right now, the deadline will be right now plus 30 seconds, right? This is basically what block timestamp is for. And you can use blocks time inside any function, and it's going to return the time where the function is being called. You can use this for measuring times, for deadlines as well. You can use this for a lot of useful cases. Yep. And now we're going to work on the execute function. And as it says here, the execute function, anyone will be able to call it just once after the deadline has expired. We're going to also test it in the debug contracts tab. And yeah, okay, let's go. And we have some checks here that we're gonna use. Sticker.sold, yeah, simple contract. Oh, okay, no one has asked about this yet, but we have an external contract here that is just for testing purposes. But here is going to allow us to learn how to call functions from this other contract inside this staker contract. For now, we haven't seen anything about this. Yeah.
Why does it use a constructor?
The contract? Because okay, so you mean the version of Solidity? The constructor was used before in the older versions of Solidity, yeah. But it allows us to initialize variables that on deploy time.
I know, but why does it initialize that contract only one time?
Okay, yeah. As I said, this example external contract is just a test, but for example, it could be useful for setting up for example, if you have a factory contract. I don't know if you're familiar with a factory design pattern, but let's say DeFi. You have a factory contract that deploys pools every time. And when this pool is deployed, you want to keep track of the contract that deployed this pool contract. and this is going to be on the constructor of the pool contract. You can initialize the parent contract here in the constructor. So now the pool contract will be able to see the address of the parent contract, for example. Yes.
And why you could like import the entire contract, right?
The methods?
Yes. But in here, I don't understand the difference.
This one here. Yeah, okay. We can see it, we can try to see it.
Oh.
Yeah, here it is. Yeah. So this contract just has a completed boolean. Yes.
I understand.
We're gonna initialize it here, and we're gonna use this complete boolean just to keep track on some things. But we're gonna do this later. Yeah. Well, as I said, this is not very useful now, but there are some other very useful use cases that you have for initializing other contracts or calling other contracts. One of these is also the, for example, chainlink VRFs or oracles. You're going to have to do this to call contracts from them. I believe we already, we already added the deadline variable here. And we're going to work on the execute function. So function execute public We're not going to receive any parameters right now. We don't need them. But here inside, we are going to require that the threshold is met. That means that the total amount staked in the contract is more than 1 Ether. Because we have said this already when we deploy the contract. So we're going to use the special require function. This is a function that is going to return an error if this condition is not met. You have a condition and you have a return message, right? So for the condition, we're going to use that the threshold or the balance in this contract, right? The balances. Oops, I'm sorry, I forgot about this. Address this. It's more than the threshold. If it's not more than the threshold, we will return an error message. You have a question? No? Yeah? Okay. This is interesting. The editor is already telling me that this function can be restricted to view as it is not modifying any variables in the contract. Because we haven't yet finished the execute method, it's telling me this. But this warning is going to go away when we code some more logic here. Yeah? And here it says in the comment that you should call the example external contract complete method if the threshold is met, right? So we're going to do this right now. We have a method here all ready for us. We can just copy and paste it. I need some water, just a bit. Sorry. In the meantime, if anyone has questions, I can just go to your PCs and help you with the workshop. If you're having some trouble verifying the transactions, yep, you can just call me. Yeah. The purpose of this is just that we know how to call an external function from another contract and to check on a variable, in this case the completed one. Yeah, like it says here. You can check the completed or not in the example external contract. Here's the condition that I told you about. If the balance of this contract using this function address is over the threshold by the deadline, you will call this. So how do we do this condition, right? We haven't touched the deadline yet, so we're gonna use the deadline now. I have it already here, so I'm gonna try to bring it up. Yeah, here it is. What we did here is just call the complete method, but we haven't checked if the deadline is met. Okay, so this is the condition. First, we're going to require that the deadline is already passed. For this, we are going to use the block.timestamp variable that I told you about before. And if the deadline has not been yet met, we're going to return this error message, deadline has not passed yet. Okay. And here we have the condition of if the balance of this contract is more than the threshold, we're going to call this complete function from the external contract, which is here, right? This one here. And if not, we're going to allow the users to withdraw, because one of the premises of this contract is that, if the threshold was not met, we should allow every user just to withdraw their funds, because the contract did not finalize correctly. And for this, we haven't set up this variable yet, and we'll do it right now. This is just a simple boolean over here. And we're going to initialize it to false. So no user can withdraw funds unless this has been executed. And as we already checked this here, we can just remove this one here. We already checked the threshold in this condition. Okay, so let me see where we are on the guide. Yeah. Since we initialized the deadline with the 30 seconds plus, we're only going to have 30 seconds after the deployment of the contract to see if we can finalize it or execute or complete the staker contract, calling the external contract. But if we want to check on the time, let's say that we modify this variable to be like, I don't know, 6,000 or 7,000 seconds more time, we should allow the user to check on how much time is left to be finalized, to be able to finalize or complete the contract. So for this, we're going to work on this time left function, which is going to return how much time is left before the deadline is met. Right, I'm going to have it here. Very simple function. It's just a public view that is going to return a number. And this number is going to be how much time before the deadline is met. And for this, we're going to do just this abstraction from deadline and blocks timestamp. Very useful. And here is the last core function of this contract, which is the withdraw function. And we're going to allow the users to withdraw once the contract has finished or met the deadline and it has completed, but the threshold has not been met, which is going to go in here. So here is going to be the open for withdrawal is going to be set to true, and we're going to use this variable to check for if the user can withdraw the funds. This is a more complex function. I'm going to explain everything bit by bit. So right off the bat, we have the require here that's going to throw an error if we call the function and it's not open for withdrawal. Okay. So if this variable is set to false, the withdrawal is not allowed, and it's going to return this error message. And now we're going to use this helper variable, the amount variable, to check on the balance of the user that's sending the transaction. We're going to require that this balance is more than 0, and we're going to call we're going to send the funds that this contract has, or the amount that this contract has, to the user. Okay. And if the transaction fails, we're going to send this error message here, fail to send Ether, and just revert the execution, right? And if not, if it was successful, it's going to just clear off the balance of message.sending. It's important to follow this pattern of checking first, meeting all the requirements, then and finalizing or executing, returning the status of the transaction, for example, and then finishing off with modifying the variables. This is a more advanced topic for avoiding reentrancy attacks, but it's nice to have it already. Any questions about this function? Okay.
Maybe 44 line, ball, send,
Comma?
Comma, yes. Then comma and nothing. What is the nothing space?
Okay, yes, it's a little weird, but to send Ether from a smart contracts, you have a lot of different methods. You have the transfer method, you have the send method. These are functions that are available to you from Solidity. But in this case, we're using the lower level call, which is this one. We're having the user send this call with this lower level call and sending the amount here as the value, right? And this is going to allow us here to have this return status. Otherwise, the other functions just send the Ether and you don't get any feedback. But for this one, we have this feedback of Boolean sent. This comma here is for yeah. This comma here is because here you can get like some other parameters, but for now we don't need them, so we just leave it blank. But now we have this feedback and we can use that one. Yes.
So what is after amount, the curly brace, then there's the quotes, or what is?
This is call data. If there's call data, if the call to any contract because you can call more than just sending Ether with this called lower level function. If that function receives any call data or any parameters, you just send them here inside this. But since this is just a transfer, we don't need any call data. Yes.
So what are like the risks of using the low level call function?
I don't know if you can explain that. I'm not really sure.
Using the low level would maybe more efficient because we don't need to pass the data. We don't need to pass the data to the call data to the function, so we just can send in the value. So we
it's a little more gas efficient, like you said, yeah. But as for the risks, maybe you can just send wrong call data and make the function revert because of these wrong arguments. But if you mean on the vulnerability side, I'm not really sure if there's if it leaves open to some vulnerability attacks.
Can we use payable messenger and transfer?
Yes, you can also use that one. Yes. Mm.
What difference between use messenger call and payable? What difference?
The payable.
Yeah. What difference from this method to the payable?
To the transfer one.
Yeah.
Yeah, I believe there's some considerations. I'm not really sure. I'm gonna have to check that one. But if I remember correctly, the transfer method it's not used too often right now these days. Yes. So the other one is more the send method is not used these days. Yes. But I'm gonna check on that after. Yeah. Okay, so now that we allow the users to withdraw the funds, our contract is ready, and we can test it here in the interface. Oh, we can deploy. We should deploy the contract now that we have some changes. Remember to do this with yarn deploy. Okay. So the contract has been reset. We have 0 Ether in the contract, and we should test the functions now. We're gonna stake a little bit of ETH right now. One ETH. We can get some more funds here. Right here, okay. It hasn't updated yet. Okay. I'm not really sure why I'm getting these warnings. I guess it always happens like this, but I will check right now. But for now, we can see that the transaction has completed successfully, and then the contract has 1 Ether in there, right? You can test it as well on your side, and you should see also the balance here, everything working correctly. Oh my God. And we're going to try to execute this contract. As you remember, execute is going to call the external contract, and it's going to set the boolean complete to true, right? And this is going to have this is going to allow users to get their rewards or their stake back. The execute function is going to have the check if the deadline has passed, and then it's going to check if the threshold has been met. Since we already sent 1 Ether, the threshold is already met. So we can send the execute transaction. The transaction is successful. We can see it here. We can check it on the contract. Let me just close this. Do you also get these warnings as well? Maybe I did something wrong in one of the methods. But if you have these warnings, if you don't have these warnings, let me know. Yeah.
It got reset from scratch. The balance is 0.
This is the example external contract. Yes, this one does not have any balance, but the staker one it has. Yeah. Open. We can already see the variables that we have set up here. time left, threshold, open for withdrawal, example external contract, and the deadline. Yeah, this is the ones that are returning some weird value. Yeah.
Oh, because maybe you don't have a return statement on the function.
Oh, it should not be that. When we have a return statement, it's because we are returning a value or something like this. But for
But we're returning that open for withdraw equals true.
I'm sorry, I didn't.
We're returning the boolean, right? Open and withdraw equals true.
No, we're just setting it up. We're changing it. Yeah. No, we're not returning it. We could return it if we wanted to get some value, but for now we just want to change it.
Maybe because
Yeah.
I was in the last function you were showing, maybe because see you have that it's returning the uint, but the uint is like not defined. Maybe.
Here?
Yeah, do we need to like define the uint?
Oh no, this is just to in the function signature. It's just to say that we are gonna return a number, and in this case we're returning the 0. But it's not a requirement to initialize any variable here. So it's not a requirement. Yeah. I'm gonna try to send this the complete function now. The complete function is false because I haven't executed the staker contract, but I'm gonna try to execute it right now. Oh, I think I already did it, right?
Yeah, it worked. It says status success.
Yeah, it did work, right? Now it won't work. That's pretty weird. I'm gonna check on that, but I'm gonna see if I can withdraw the funds that I have staked in the contract. Let's see if I can do it. Okay. It did succeed, but I don't see the funds from in my wallet. Do you guys get it? You tried it already? No? Yeah? It worked for you?
Yes.
Nice.
Send and the deadline and the sample and I can't see and it's not open yet.
Oh yeah, because
I think I set the deadline so it's not open.
Oh, you set a very long deadline.
Yes. Not very long, but I just deployed it.
Okay. 30 seconds. Let me see what I did. Open for withdrawal, amount, balances.
30 minutes for the deadline, 30 seconds for the deadline.
Withdraw not open yet. Sender.
It's nearly the same.
Can you send me this so I can just paste it? Yeah, I think it's better, and we can try it live.
Okay.
Mm-hmm. Yeah.
Thanks.
Nice. Oh, you already have the receive function. Nice. Yeah. Okay, so I will try to redeploy the contract and test again if it works. Maybe I did something wrong in there. Okay, let's go. Yeah, so now I have the time left, the threshold, everything is working fine. And as the contract reset, we have 0 ETH, we can stake some ETH. But now we're gonna do it differently. We're gonna try from the staker UI directly. I'm gonna get some more funds, I'm gonna send a transaction to stake some more ETH. And it worked, right? And we can see the values reflected here, everything it worked. And now we can execute the contract. I don't know if how much time you have for the deadline? 30 seconds? 30 seconds. I believe it already passed, so we can go on and execute this contract. Deadline has not passed yet. We can just wait for a bit. And what else? You can see some events here. This is what I was talking about before on the events, emitting events. This is mostly used for displaying data on the interface, right? So you can see it here. It already displays the 0.5 ETH that I already staked in the contract. And if I do some more staking, it will display it there, right? You can see the events here. This is all thanks to the event that we coded. You can see this one here. And now I believe the deadline is met. We can execute the contract. And the transaction completed successfully. And since the contract is executed, we can just withdraw the funds right now. Right? And I should see 0 ETH in the contract and my balance returned to my wallet, right? You can also try this with other users, other wallets. You have a question?
Yeah, I missed how you fixed those errors. What was the issue?
Oh no, I asked you for the code. Maybe I did something wrong, but I will check what I did wrong. Yeah, I will tell you later. What else? Yeah, that's basically it. I didn't explain the last function, but this one is really fairly easy. Then the last challenge of this lesson was to code a function. Let me see. Yeah, a function that allows the contract to execute the stake function once it receives some ether. Yesterday we already saw this with you, the receive function and the fallback function. You had some questions about this, but now we're putting in practice, right? So we have the receive function, and we just it's like inheriting this function from Solidity, from the smart contract itself. We code it, and we can execute any other logic inside the receive function as we want. And so when the user sends ether to this contract, like a simple transfer, this contract is going to execute the logic inside the receive function. In this case, when we set ether to the staker contract, the staker contract is going to execute the stake method. And the stake method is going to use the same value. Yes?
What if we are having like multiples, like a stake function? If we have to choose, how do we handle it?
If I have, sorry, what?
If we have like multiples stake function, like we have multiple option and the different method, how do we like if the money is transferred to this contract, right, it's gonna call receipt, right? I understand, right?
I think if I have some other state functions like this or no,
Like leg two,
stake 2 or
yeah.
you can call it in here. Like you can call many methods in here, but every transfer of Ether to this contract is going to go through this receive function, and it's going to execute that it's everything that's inside here. There's also the fallback function, which is basically the same, but it has some differences on error handling. But I don't know if I got the question right. Is that the question? You can show me an example if you want. Yes, I can go up there. And yeah, we can try to test this function as well. And this will be the last function for our contract. Everything's already there. Let's see, I have this staker contract. The on Block Explorer. Nice. This is another cool feature of Scaffold It. You have the Block Explorer built into your local node. So this Block Explorer is using this chain that we initialized here with the yarn chain command, and it's gonna display every transaction that we're doing on the local chain. This is very useful for when you want to debug contracts and see the status of transactions. Yeah, that's basically it. It's a very useful feature. Mm-hmm. I don't know if you have any more questions about this. Yeah. Okay. Thank you. If you want to check the solution on this, you have this link here. I'm going to send it to the Discord as well. Here you have, yeah, everything solved on this lesson. And you can use this one. You can follow the steps of the guide to deploy the contracts and ship your frontend. You can also send these links to the Speedrun Ethereum platform, and they will check on your results and give you a grade and everything here. You can track your progress here on Speedrun Ethereum. But this is going to go on your way. It's fairly easy, just follow some step and you will be done with checkpoint 4 and checkpoint 5. So thank you guys. Any other questions? I will go with you. Thank you.